Well, let's get to factoring this trinomial right here. Well, for these exercises, I'm looking at this form of equation, but we're going to simplify this. A is always 1 in this case. In other words, there's only one z squared. So I am going to factor this into the product of two binomials. I'm just going to start with this. Now, a lot of students have difficulty with this. Let's try this easy method. Let's just say I'm looking at these three terms, and I'm looking at this c term, and I see 48. Now, I know I'm multiplying to get this term, and because this is a negative sign, I know I'm subtracting to get this coefficient. Well, put that in English, we're looking for criteria like this. I want to imagine two whole numbers, that is if it can be factored at all, that have a product of 48 and a difference of 8. So we're going to explore the whole number factors of 48 for this problem. Now, I know you may have called it the rainbow. I don't really care what you call it. But let's just review our divisibility rules. We know, in this case, all these numbers, or any number, divisible by 1 and itself. So there we go. And we work inward. Now for the green. Well, it's an even number, divisible by 2. Well, 2 times 24 works good. Well, 4 plus 8 is 12. That's divisible by 3. That means 48 is divisible by 3, and that's 3 times 16. So you're probably getting the hang of this. Divisible by 4, well, let me see. You can see that. 40 and 8, they both are divisible by 4. So I'm going to put down a 4 here, and that's going to be 4 and 12. And finally, my last two numbers. If this number is divisible by 2 and 3, it is indeed divisible by 6. And 6, of course, 6 times 8. And now I have all the pairs. Now, I'm not saying you have to write this every single time, but you might be thinking this, and you might just explore the relationships. Go ahead, do yourself a favor, and write this out for one or two of these numbers you want to factor. So let's start looking at, well, let's look at the properties of two factors taken as a pair. 1 times 48. 1 plus 48, 49. 1 minus 48, 47. See a very large sum and difference. How about 2 and 24, the two green numbers? And you can see, well, 26, 22 for sum and difference. Moving into the yellow, 19 and 16. Notice what's happening. The sums and differences are getting smaller, but they're also diverging. I can see 47, 49, very close. 19 and 16 moving apart just a little bit. Over here, in the blue, the difference of 16, or sum of 16, difference of 8. And finally, I can see here a sum of 14 and a difference of 2. In your mind, you're probably imagining when the difference is small, you're thinking on the inside of these rings. When the difference is larger, you're thinking towards the outside of these factors. And of course, sums, well, we'll get to sums with the next exercise. But as I recall, in this specific exercise, we're looking for this. And I think you can see where this is going to take us. Well, now let's finish up this exercise right here. We started this before. We've got our two z's, leading terms in those binomials. And now we've listed our factors from the rainbow. And it's pretty clear to see the two numbers that meet this criteria are going to be in fact, our two blue numbers, I'll call them. So I'm going to say 12 and the number 4. Now, we're just about done. And I teach to do it this way. We'll worry about signs later. Well, later is now. And again, we went for a difference because of this sign. The C term is negative. So I went for that difference of 8. And now I have to look at this. I've got a plus sign there. Okay? I know what I need here. I've got one positive, one negative. And I know that my middle term, my B term, is going to end up positive. So I'm going to take the larger absolute value, the larger magnitude, and assign that the plus. Now again, this is simplified. Our a is 1 in all these exercises. It'll get trickier later. And I think this is going to be my negative. We can check this out with our FOIL, and certainly we can see z squared, outer minus 4z, inner plus 12z. That's where my plus 8z comes from. 12 times negative 4 is negative 48, and we're done. Let's do a few more, but of course, we're going to speed it up just a wee bit. Let's try another one of these. Here with my trinomial, again with a leading coefficient of 1. This time, my c term is positive. My last term is positive, and my middle term is negative. Well, this is all I want you to focus on right now. I know you know how to do that whole factor thing now, so let's just write our criteria out. I want two numbers with a product of 72, but this plus sign tells me I want a sum of 17. So, well, let's just look at these factors, and we're going to write them all out. Again, you might be doing this in your head. You're imagining those two numbers, 72, but I want a sum that's a small sum. So I'm looking for two numbers close together. And right there in the brown is what I've got. I've got 8 and 9. So I can say put a 9 there and put an 8 here. So far, so good. Now the signs. This middle term is negative. Well, if I'm going to have a positive here, my middle term's negative, I must have two negatives. Minus 9 and minus 8. Let's look at this. B squared, outer, minus 8b, inner, minus 9b. That's my negative 17b. Negative 9 times negative 8 is plus 72. Let's do another. So let's see if this one can be factored with whole numbers. Well, it's in your textbook, so you know it can. Here we go. 1 times 64, reviewing this very quickly. And I'm looking here. I've got factors 2 times 32. Is this divisible by 3? 6 plus 4 is 10, not divisible by 3. It is divisible by 4, however. That's 4 times 16. Now this one's a little different because it has this factor, 8. So it happens to contain a perfect square. 64 is a perfect square. That'll show up more on some other videos. So here we go. I've got my signs, and I know my criteria. I want a product of 64, and this tells me a sum of 20. Well, no problem there. I could see right there, 4 and 16. So I'll just put that 16 here, and I'll put this 4 over here. And, well, I've got a middle term that's positive. I can get, well, two positives or two negatives. It must be two positives, since the middle term is positive. First, p squared, outer, plus 4p, inner, plus 16p. That's your 20p, plus 64. Okay, now we're going to set it equal to 0 and use the zero product property. Well, here we have another trinomial, but this one's different. This is an equation because it has an equal sign. So now we can solve it. Just like we did before, I'm looking at these numbers here. I see a 30, product of 30, negative sign tells me a difference of 7. This time, I'm going to change the steps up just a little bit. I know I've got one positive, one negative. Now I just have to make sure I put the numbers in the right spot. So the factors that we've all, well, I can imagine those. I'm looking at those two orange ones because they have a difference of 7. So right there. Now we got to put them in the right spot. I'm going to say negative 10, positive 3. A quick check on our FOIL, n squared, minus 10n, plus 3n, minus 30. Checks out okay. But now we're going to use one more step, and this is called the zero product property. It tells me that if two numbers, in this case expressions, multiply together to make 0, either the n plus 3 is 0 or the n minus 10 is 0. Well, what two numbers satisfy that? That is, of course, going to be negative 3 makes the first expression 0 and positive 10 makes the other. Now let's close out this quick video with one more example. Here we go with an equation. But this one looks funny. We're going to have to put it in the correct form first. I need everything on one side. Add that 23m to both sides of the equation. I can solve it now because it's set to 0. I can see I've got my squared term, I've got my b term and my c term. I'm imagining that I'm looking for two numbers with a product of 22, and a plus sign tells me a sum of 23. Now that one's pretty straightforward, and I know you don't even need to list those, but there you go. And it is clearly, well, going to be the 1 and the 22. Now, I'm going to put this 22 here and this 1. I'm going to check my work. M squared, first, outer 1m, inner 22m. That makes 23m. And the c term, 22. We're good. Zero product property now tells me that either the first expression is 0 or the second expression is 0. And what value of m will generate that? Well, the 1 over here, I can imagine a negative 22, and over here a negative 1. So those are your solutions. Well, I hope this has helped. Stay with your book, and happy math.